A sonometer wire is vibrating at frequency F0. If the tension in the wire is doubled while the length and the mass per unit length are kept constant, what's the new frequency of vibration? Now, this question is actually coming from sound waves. Now, they said a sonometer wire is vibrating at frequency F0. So, the correlating equation here is frequency of the wire is equals 1 over 2L square root of tension all over capital letter M. This is not mass. This is mass per unit length, also known as linear density. Now, a sonometer wire is vibrating at frequency F0. If the tension in the wire, if the tension in the wire is doubled, while the length, this length, 1, and the mass per unit length, now both of them are kept what? Constant. Now, when both of them are kept constant, we can see that the frequency now will be directly proportional to only square root of what? The tension. I hope it makes sense. Now, when these two are kept constant, we see that the frequency, which is F, will be directly proportional to what? Square root of the what? Tension. For instance, if the question is in this way, when the if the mass per unit length and the tension are constant, now it means that the frequency will be inversely proportional to what? Length. I hope it makes sense. But the question says that 1, 2 are kept constant. Does it make sense? Then we'll say that frequency is directly proportional to square root of what? Tension. Now we have that F is equal, when we remove this, equals K square root of what? T. Now make K subject of formula. We have over square root of T all over square root of T. Cancel, cancel. So we have that the constant K is equals F all over square root of T. Now if we have something like this, we can say that F1 all over square root of what? T1 will be equals F2 all over what? Square root of T2 will be equals F3 all over square root of T3. It keeps going like that. So, but we have to stop here. Now, let's go back. A sonometer wire is vibrating at frequency F0, the fundamental frequency. Now, it means that the F1 is equals F0. That's this F1 is equals, so this is the first frequency. So, they say that it is F0, right? Now, they say if the tension in the wire is doubled, if the tension in the wire is doubled, now the question is, what is the new frequency of what? Vibration. If the tension in the wire, that means that the tension in the wire becomes T2. I don't know if you understand. If the tension in the wire is doubled, meaning that if T2 is equals 2T1, now it means if you want to get the new tension, you have to double the first tension. Now it means that T2, if the tension in the wire, it means that T2 is equals 2T1. Now they're asking us what is the new frequency of vibration, which is F2, right? What is the new frequency of what? Vibration. Let's go back. So from here I can see that F1, which is F0, I can see that F0 all over square root of what? T1 will be equals F2 that we are looking for all over square root of T2. We see that T2 is equals 2T1. I hope it makes sense. Now, let's make F2 subject of formula. We have cross multiply. F2 times this, we have F2 square root of T1 will be equals F0, this times this, F0 times square root of 2T1. Now, all over square root of T1, all over what? Square root of what? T1. Cancel, cancel. So I have that F2 is equals F0 times square root of 2 times square root of what? T1. Now, this square root of 2T1 can be seen as square root of 2 times square root of T1 all over square root of T1. Now, this can cancel this, right? So I have that F2 is equals square root of 2 what? F0. Now, they said the new frequency of what? Vibration. Now, how can we say this? It is F2 is equals square root of 2 times F0. Or you say that F2 is equals F0 times square root of what? 2. And that's our what? Final answer. Have a nice day. Like, comment, share, and follow Kosis Academy. Bye-bye.